This is Computer Programming 1 from the University of Washington. I'm Martin Dickey, and today in Lecture 7 we will finally begin talking about something I've mentioned many times already, functions. In today's lecture we'll see what a function is, what function control flow is, how we can define a function, and some technical topics such as the two meanings of the void keyword. We'll also take a quick look at pre-written functions in C. This list of topics does not begin to exhaust the concepts that we will need for functions in writing programs in this course. We'll have at least 2 more lectures in which we further deepen our understanding and familiarity with functions. Like conditionals, functions are essentially concerned with control flow. That is, the order in which statements are executed. So far, we've seen 2 major forms of control flow. Sequential is what we started with. Statements are executed one after another from the beginning of the program until the end. With conditionals, the if statement, we have a great deal more flexibility because we can now choose which statement or which group of statements, because we know about compound statements, are to be executed. The last major form of control flow is the function. As I've alluded to in the past, a function is a section of code, a chunk of code, somewhere else than in your main program. This chunk of code might be in your program elsewhere, or it might be in a file written by someone else, perhaps stored in a library on the disk. The idea is that your program, the black box at the top, is executing and wishes for the function to then execute. This is referred to as a call to the function, and we will frequently use this word call to mean the process of going from your program to another one, to a function. When the function is finished, it will come back to your program, and we'll refer to this as the return. So from your program, we're breaking out of sequential order with a call, and we're returning to the main stream of control flow with a return. This is the basic picture to keep in mind all through this discussion of functions. In a sense, all we'll be doing is filling in the many details that will make this work and make this useful in our programs. You might wonder why we bother to do this. Well, I'll mention several reasons as we go along and later on in the course as well. But to illustrate the usefulness of this, I'm going to use a particular example today, and I'll use it quite often. Although it may seem rather simple, it will help us to see this concept in action. So here's the situation. Let's suppose we're writing a program that's going to display lots of messages on the screen. Perhaps we're displaying a user manual for repairing an airplane. So the primary job of the program is to print many error messages. Sorry, many messages. They may not all be errors. To make the messages more readable, periodically we'd like to display a couple of lines of asterisks on the screen. This is simply to make this long series of text messages more readable. So, all we're going to do in our example is focus on this process of printing the 2 lines of asterisks. Now, this is not in itself a difficult programming problem. This is something all of you are now able of sitting down and writing immediately, and the code that you might use is shown at the bottom. A set of 2 simple printfs that put out the required number of asterisks and follow them by a line feed. It may seem like a small example, but it'll be just the right size for illustrating the concepts today. Those 2 lines of code, of course, are not the whole program. The program itself is generating messages, aircraft repair, or whatever the application is. So the entire program consists of many other parts. However, sprinkled throughout this program, these two printf lines occur again and again. Now, what I've shown here is a version in which we see 3 of these sets of two printf lines, but perhaps the final program might have them repeated many times, perhaps dozens or hundreds of times, perhaps once for each page of information being displayed. Is there, in fact, anything wrong with this? That's a legitimate question. Why not accept this solution? It does work, assuming that we get the rest of the program right and we don't make any mistakes in typing. This would fulfill the problem specification. But there are things wrong with it other than its correctness. These issues have to do with things like how hard it would be to change the program if I don't like the original design, or perhaps more importantly, if the client who commissioned this program doesn't like my design, or if the client changes their mind. Clients have a way of doing that even after you've delivered perfectly good working software. Think about how much work it would be if the client did want to change. Say the client decided we didn't want 2 rows, we wanted 3 or only 1. Instead of 12 asterisks, they want 20. Or instead of an asterisk character, they want a hyphen. Or they want to have the date and time printed at the beginning of each line. You can go on and on. There are all sorts of ways in which we later might decide that our original 2 lines of asterisks wasn't enough. We would have to go back then and do what? Change every single place in the program where those 2 printfs occur. Okay. If this is a big program, it might be a lot of work. It might be hard to even find all those places. We might be working late at night and simply overlook some of them. Or we might inadvertently change some printfs that shouldn't be, that look similar to the ones we want, but actually are serving some different purpose. Functions will help us remove these difficulties. Here is the big idea behind functions. And as I go through these points, think in your mind about how that applies to the problem I just mentioned. When we're thinking about functions, we're thinking about some sub-problem of our entire big original problem that has to be solved. We take this sub-problem and solve it by itself and write the code to solve it. And here's a big idea. Write that code only once. Okay? So we've solved the sub-problem. We've written code for it. Now we're going to give that code a name. It's that operation that makes that code into a function. Before it was just a bunch of statements that do something, that solve a part of a problem. We're going to put a name to that set of statements, and now we have a function. Once we've done this, we can do something pretty nice. Every time I need to solve that subproblem, I can simply call that function using its name. And here's that word call, which I mentioned a little while ago. Call means leaving your thread of execution in the program, going off to the function wherever it happens to live. When the function is done, it will return to your part of the program. Okay. This slide really has the whole story on it. It not only describes what we're going to do with our printing asterisks program, but essentially it describes what we always do when we write functions. Now, functions can get tricky, get complicated. There's going to be lots of new terminology. There's going to be lots of details and exceptions and things to remember. If you get lost, don't panic. Many students have found themselves in the same position as you have before you. Take a deep breath, go back, and review what you already know. If you come back to this slide, you might find that it's an anchor point for keeping this big picture in mind. What we're actually doing. We're taking code, we're giving it a name so that we can use it somewhere else. Okay. Many, many details to fill in now, but that's the big idea. Now let's start talking about some of those details. In our particular example, the two lines of code we want to wrap up are these two printfs. Now I'll show you a little bit later exactly the syntax for wrapping them up. Instead of doing that, let's show how we would call the function once it's been wrapped up or defined. On the left-hand side is our original big program, and I've removed from it all of those printfs. What's there instead? Well, if you look at this, you'll see that I have the name of the function, print banner lines. That's what I was going to call the function. So instead of putting the printfs there, I put the name of the function, and this serves as a call to the function to make those statements execute. What are the parentheses? They're just part of the required syntax for the call, part of those many, many details that you'll be learning as we go along. The key concept is that instead of the printfs everywhere in this program where they were before, we have a call to the function print banner lines. The printfs are now inside print banner lines. That's the big idea. Think about this now, new version of the program. What would we have to do now if the client wants a change? If the client wants to print dashes instead of asterisks in all those places, or print 20 instead of 12. Okay. Think about that. I think you'll see there's a lot less work involved. If you don't see this, that would be a good thing to discuss after watching this lecture. Convince yourself that there is less work involved and see why that's the case. So far, we've seen what a function is. We've discussed the notion, the essential concept of calling and returning. That's our new control flow. And we've seen what I hope is a somewhat convincing motivation for functions. We'll see other motivations throughout the course. Coming right up, we're going to talk about the C syntax for defining a function, and then talk about some built-in C functions in a very quick way. In another lecture, we'll go into other issues, particularly how we get information to a function and from a function, to give those statements information to work on and to get answers back from them. Let's look at the actual C code for defining the function. You see it right here. This is a very typical pattern for a function declaration. Some of the things in here might be obvious, others might be a little mysterious. I'd like to highlight for now two key features of this function definition. One is the function name itself. So clearly, if we're going to name a function, we have to state what that name is. And we have done that there. That comes near the beginning of this function declaration. The other of the two key features I want to highlight right now are the statements themselves that are going to be executed. This has a name. It's called the function body. And our old friends, the curly braces, are back. Here's another case where curly braces are used. The function body is always enclosed within a set of curly braces. Familiar notation by now. What can you have in those curly braces? I.e., what kind of statements can you have? And the answer is a nice one, I think. Anything. You can have anything you want in there. As many statements of any type that you might need to implement the algorithm that your subproblem is solving. Now, those two key features are not quite all that's there. Just to avoid being too mysterious, let me point out a couple of other things without going into detail. There's a keyword void in front of the function name. That tells the C compiler that this function does not return a value. There's another use of the word void in parentheses after the function name. This says that the function has no parameters. Well, I've just gone ahead and introduced two brand new pieces of terminology, return values and parameters. These are both really important, and we're going to spend quite a long time talking about both of these. But we won't do that right now. We want to focus on the larger concept involved here. However, just to solve the mystery, that's what those two uses of void are doing in this particular example. Actually, we've been using functions for quite a long time in this course. Printf and scanf were functions. That was not a mystery. I made that clear when we talked about printf and scanf. Didn't try to hide that from you. However, I did try to hide something else from you early on, and that was what this main keyword was, or main identifier that occurs. And I said it has to be there. It's boilerplate. It's going to be in all of your programs. We know now something about what that is. Look at the pattern. Main, a name, and then a bunch of statements in curly braces. What we're looking at is a function definition. So when you write your program using that boilerplate, what you are doing is defining a function whose name is main and whose statements to be executed are all of the statements that have to be in the curly braces. So perhaps that clears up a little of the mystery of the boilerplate in the programs we've already written. It turns out that beyond scanf and printf, there are many other functions that come packaged with every version of the C compiler. These are generally placed into files called libraries, and every C compiler will come with a set of libraries. They're called standard in the sense that they're always there. So whether the software vendor is Aldus or Microsoft or Sun, if it's a C compiler, you can count on there being certain libraries with definitely defined and specified functions in them. In the boilerplate, we had another mysterious line. Remember that? Pound include, stdio. I can now say just a little about what that is, just only to remove the mystery of it. That is telling the compiler that we're going to use a particular one of these standard libraries. There's a library called stdio. And this line says, I intend to use that library. Why do I intend to use it? Because, as it turns out, that's where printf and scanf live. They're inside that library. The C libraries include lots of other useful functions. For example, many mathematical functions, trigonometric, calculation, statistical, and so forth. We've now seen the big idea of functions, which is wrapping up a bunch of statements and giving it a name so that we can call it when we need it. Next time, we'll continue this discussion of functions as we look at how values can be passed in and how they come back. If you're a little uncertain about the material we just did, don't panic, but do take the time to go back and review it, because what we do next time won't make any sense until the basic concepts are clear in your mind. I look forward to joining you then.